Single one of your contracts is as follows. You always 100% need to have tests that pass on a local Brownie spun up ganache instance. That should be priority number one to get all your tests to pass on this. This means that you will need to deploy mocks. After that, the other place you absolutely need to have tests or do some type of development is on a test net. These are going to be what's known as your integration tests, and we'll talk more about those later. So those are the two places you always need to have tests, development and a test net. I think testing on mainnet fork and your own local ganache are optional. Testing on mainnet fork can be done and probably should be done whenever all of your contracts and all of your interactions are going to be on chain, on one chain without any external off-chain components. Testing on your own local ganache is really more meant for tinkering and kind of exploring and seeing things yourself. So that's going to be the setup here. So great, now let's move into our most challenging example. Once you pass and once you complete this example, you basically will have all the tools to be an incredibly powerful smart contract developer. Then after that, we're going to show you the Chainlink Mix package and how to do what's called a Brownie bake to automatically open up this package with all these scripts and all these contracts pre-built in. This is going to make our lives substantially easier and faster for deploying our smart contracts. However, let's go through the process of understanding all the pieces that are going to be inside of this Brownie mix. Are you ready? You should be. Let's get excited and jump in. Okay, so let's get into our most advanced smart contract project that we've made so far. This is going to be the best example of a full scale application. And by full scale, I really mean end-to-end full suite of a Brownie. All of our smart contracts are really solid here. What we're going to want to do is create a lottery application where anybody can enter the lottery and a random winner is selected. So let's get to it and let's get started. So first, of course, we're going to make a new directory. We'll call it smart contract lottery. CD into smart contract lottery, and then open that folder. And great, we are now in our lottery application. So let's go ahead and start a new project. Brownie init, we've got our project here. Now let's create a quick readme.md to explain what we're going to be trying to do here. So number one, we're going to say users can enter the lottery with ETH based on a USD fee. So for example, let's set the price to be like $50 and the users actually pay with Ethereum. So we're going to have to get that conversion rate. Number two, an admin will choose when the lottery is over. And then three, the lottery will select a random winner. Now, something important to note here is since we have an admin here, this means that our application isn't necessarily going to be truly decentralized because we have a single person chooses when the lottery is over. We could scale this out to have maybe a DAO being the admin or something like that, or we could have the lottery automatically open and close based off of some time parameters. But for the moment, this is the setup that we're going to have. Keep in mind, even though this is much less decentralized, it's still going to be a great use of smart contract technology. So first thing that we're going to get started with, of course, is our lottery contract. So create a new file called lottery.sol. And let's begin with our initial setup here. So let's choose our version, Pragma, Solidity, caret 0.6.6. And this will be the version that we want to work with here. We'll do contract lottery, bracket here. Now let's think for a second on what some of the functions that are going to be, what our main functions are going to be here. We'll probably have a function enter. That'll be public. We'll probably have a function get entrance fee to get the entrance fee of the lottery. We'll probably have a function start lottery that only the admin can call. This will be public as well, which means we'll also probably have an end lottery function. And those are really going to be the main functions. The user can enter based off the entrance fee. We can start the lottery, and then of course we can end the lottery. So let's get started with this enter function just because this is most likely going to be the entry point. As we know, since we're going to want them to pay using this entry function in Ethereum, we're going to need to make this function payable. And in here, we're going to need to keep track of all of the different players, everybody who signs up for this lottery. To keep track of all the players, we're going to make an address payable array. We'll make it public, call players. And anytime somebody enters, we'll just do players.push message.sender. However, right now, we're not checking to see how much value that they're actually sending. We want to set the price of this to be at least $50. So we'll say $50 minimum. So here we're going to have to do a require statement requiring them to do at least $50. In order to do that, we're probably going to need to have some function to get the entrance fee to check whether or not how much they're sending is actually $50. So let's go ahead and make that get entrance fee function now. Since we're just going to be returning a number for get entrance fee, we can probably go ahead and make this a public view and have this return a UN256. To get this entrance fee, we're first going to have stored somewhere what the entrance fee is. We're going to have to store this $50 minimum somewhere. This is something we'd probably want to set right when our contract is deployed. So where can we put stuff like that? Well, in our constructor, we'll do constructor public. We'll create a new variable outside of here. We'll call it UN256 public USD entry fee. And in our constructor, we'll set USD entry fee equals 50. Now, because I like to have units of measure always in way, we'll also do times 10 raised to the 18th. Now we have some USD entry fee. Let's go ahead and get this entrance fee. As we know, since we're going to try to get a conversion rate here, we're going to want to use a Chainlink price feed. So we can head on over to docs.chain.link. We'll scroll down to get the latest price. And we can even just go ahead and copy paste this again. But for the sake of robustness, let's just walk through again how to actually set this up. We're going to need to pull from the price feed to convert $50 to $50 in ETH. So let's go ahead and create an aggregator v3 interface, internal ETH/USD price feed. And in our constructor, we'll go ahead and set this. We'll say ETH/USD price feed equals aggregator v3 interface. And we're going to want to grab an address from our contract addresses. But of course, as you know, as we've learned from last time, we're going to want to parameterize this. So we're going to want to pass the address of our price feed as a constructor parameter. So we'll do address price feed address, and we'll have our aggregator v3 interface be passed that price feed address. Then, of course, since we're using an aggregator v3 interface, we're going to have to import this from Chainlink. So we can just go ahead, copy this from the documentation, and paste it right at the top. Or if you want to rewrite it out yourself, feel free to do so. And of course, since we're doing this import here, new file, brownie config.yaml, we're going to want to add this as a dependency. So we'll do dependencies, smart contract kit / Chainlink brownie contracts, and we'll do add 1.1.1 again, and then compiler, soak, remappings, we'll say at Chainlink equals this right here. We'll pull up our terminal, and we'll try this out. Do brownie, compile, see if we're doing everything right. We forgot an SPDX license identifier, which is just a warning, but let's add it in anyways. SPDX license identifier, MIT. I should probably spell remappings right. We'll do remappings, and let's try to compile again. All right, lovely. So we at least know that we are compiling correctly here. Awesome. So now that we have a price feed, let's go ahead and set up this entrance fee. So we're, of course, going to need to get a price from this price feed. So we can even check the documentation on how to do that. We can call this latest round data function. So we could copy paste it. I'm just going to go ahead and rewrite it. But again, we don't need round ID, started at, timestamp, or answered in round. We only need price. So we can go ahead and ignore these variables on our call. So what we'll do is we'll do blank comma, int price, and then comma, 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 equals FUSD price feed dot latest round data. And this means we're just going to get the price here. Now we're going to want to do a little bit of quick math. Typically, if we're setting the price at $50 and we have a price feed of $2,000 per ETH, we would just want to do 50 divided by 2,000. But of course, since Solidity doesn't work with decimals, we can't actually just do this. So we'll have to do 50 times some big number divided by the 2,000. So we're going to go ahead and do it like that. But first, let's go ahead and convert this price from int 256 to uint 256. So we'll say uint 256 adjusted price equals uint 256 uint 256 price. And then, since we know we're going to be using an Ethereum USD price feed that has 8 decimals, let's also just convert it to having 18 decimals as well. So we can also do times 10 raised to the 10th. So now we can have 18 decimals. Now that we have this adjusted price, we'll do uint 256 cost to enter is going to equal USD entry fee times, again, we're going to want to times it by some big number here. So we'll just times it by 10 raised to the 18th. This way, USD entry fee has 18 decimals, but it has an additional 18 decimals here that'll get canceled out with our price feeds, and the math will work, divided by price. And then we'll return cost to enter. Now, of course, since we're doing some interesting math here, it's recommended to use safe math and use safe math functions. We're going to skip over the safe math functions here, again, because in the newer versions of Solidity, you don't really have to use them. But I think it's important to note here that sending this code, this exact code to production would be a bad idea for at least the reason of the safe math functions. But in any case, we have a function here. We think our math is pretty good, but I know for a fact that my math is usually not very good. So let's go ahead and do some testing as we code, just to make sure our get entrance fee function is working properly. So based off of our last lesson, let's talk about how do we want to test this? Well, we could do a mainnet fork here because we're only working with some on-chain contracts and some math. We will at some point have to do our development with mocks and of course our testnet. I kind of want to just do a quick and dirty way. So let's try our mainnet fork just for now, just to see if this is really making any sense. If the current price of Ethereum is $2,500 or this much here, and we want the price of this to be $50, we can do 50 divided by this, and we get 0.019. So this should be approximately what we get for our ETH value. So if we were to write a test lottery.py, we were to test this function, we would expect to get 0.019, or in way, it'll be 19, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6. We'd expect to get approximately this. So let's go ahead and create a function that tests this. So we'll do test get entrance fee. And in here, we'll deploy lottery. And in here, the first thing we need to do is deploy this lottery function, of course. So we'll do from brownie import lottery. In order to deploy this, we're going to need to get an account. We are going to import our helpful scripts from the last project to this one too, so we can get our get accounts. But for the time being, we can actually just use accounts 0 from brownie. So we'll say accounts 0. Let's just start with def. Then we'll do lottery equals lottery.deploy from account. And of course, we have a parameter here of our